Hello everyone, my name is Thomas Watson and this is the Signal Jammer for my ISP project. In this video I'll be explaining what a Signal Jammer is, what the components do in the circuit, as well as a bit of background information about Signal Jammers. First off, a Signal Jammer is a device designed to block or interfere with wireless communication signals. It works by transmitting radio waves on the same frequency as the target devices, effectively overwhelming them and preventing successful communication. Signal jammers can be used for various purposes, such as disrupting cell phone communications, GPS signals, or Wi-Fi networks, and are often used for security, privacy, or military application. In a signal jammer circuit, several key components play crucial roles. These include the BC547 transistor, which is right here, as well as the 555 logic chip. Also, various different capacitors, resistors, as well as a 30 picofarad trimmer capacitor. First, I'll start with the BC547. This is an NPN bipolar junction transistor, commonly used in electronic circuits. In a signal jammer, the BC547 can act as an amplifier or a switch. It helps to amplify the weak signals generated by the oscillator circuit to a level where they can effectively interfere with the target signals. On that topic, the oscillator circuit that I am referring to is the 555. The 555 in this project is a clock signal. It continues to transmit the radio waves to disrupt the signals. Next, I'll talk about the capacitors. These are passive electronic components that store and release electrical energy. In the circuit, the capacitors are used for filtering and tuning purposes. They help stabilize the voltage and current in the circuit, ensuring that the signal being generated is clean and consistent. And there's also the 30 picofarad trimmer capacitor. Here, let me get a closer picture of that. These are adjustable capacitors used for fine-tuning the frequency of the oscillator circuit. By adjusting the capacitance, you can precisely control the frequency of the jammer's output signal to match the frequency of the signals you want to disrupt. This fine-tuning capability is essential for the effective functioning of the jammer. Now talking about the differences between point-to-point boards and strip boards. A point-to-point board, which is this one, involves directly connecting components with wires and solder, offering high flexibility and easy modification, making it suitable for simpler, temporary, or custom circuits. However, it can become messy and unreliable for complex projects. It started to devolve into that in mine. In contrast, a strip board, also known as a Vera board, features a structured layout of grids and of holes and parallel copper strips, providing an organized and stable platform for semi-permanent prototypes and small to medium-sized projects. While less flexible for modifications, strip boards can offer better scalability and a neater appearance, making them ideal for more complex and reliable circuit designs. In summary, a signal jammer uses components like the BC547 transistor, various different capacitors, including 5.7 farad capacitors, as well as 2 picofarad, 4 picofarad, 5 picofarad, and a 47 picofarad, many different resistors, as well as the trimmer capacitor, to amplify and generate signals that interfere with target communications, including Wi-Fi. This one was built for Wi-Fi. The choice between using a strip board or point-to-point board depends on the complexity and permanence of the circuit that you're building. I chose a point-to-point board just because I thought it would be a bit simpler and also a bit more flexible. Thank you for listening to my project. I hope you found it informative, and yep, have a good one.